I'm glad that I was able to attend the recent photomask technology and EUV lithography conferences, a pair of meetings that are co-located and sometimes referred to as PUV and more traditionally Bacchus. But whatever name one uses, it was a very good event this year. The presentations that make up the core of the meeting were very good. We heard some very interesting and informative plenary session talks. And for the technical presentations, the quality was also quite good. Contributing to just making it a very nice event was a positive mood. I think part of the positive mood just has to do with the fact that business is doing well. The semiconductor industry itself is doing well, and the portion of our business having to do with masks is also doing very well. We, at the eBeam Initiative reception, an event held annually in conjunction with Bacchus, Aki Fujimura showed a graph of photomask revenues. And starting in 2017, there was definitely an upturn and things continue to go well there. So I think having business good certainly contributed to the good mood. Moreover, new technology developments are proceeding smoothly. The latest and greatest in EUV technology is the high NA, and that is moving along quite well, it does seem. I think there had previously been some apprehensions about it just because we'd struggled so much to get EUV lithography working in the first place. But in one of the plenary session talks, Christophe Fouquet, the CEO of ASML, I think put this nicely in perspective. He noted that it took 21 years to go from the first publication on EUV lithography to the having alpha tools available. And then it was another 13 years from the first alpha tools to EUV lithography being used in high volume manufacturing. However, it's only been 5 years since we started to use EUV heavily in manufacturing to the shipping of these high NA tools. And I think the point being made is that there were some very fundamental issues in EUV lithography that were quite difficult to solve. But now that those problems have been solved, we can now get into a bit of a smoother cadence for the introduction of new lithographic technology. Another example of how nicely things are going with high NA. One of the characteristics of high NA lithography is that the exposure field size is only half that of the 0.33 NA EUV tools or optical exposure tools. And as a consequence, if you want to make a large chip, what you have to do is put half of your features on one mask and expose that, then switch out with a different mask that has the remainder of the features and expose that. And at the boundary between those two masks, everything has to fit together, be nicely stitched. And people have had some concerns about this, but I think at the conferences, it was shown that this is, while a non-trivial problem, it's a soluble one and can be done. So again, some of even the big concerns about high NA seem to be alleviated. Another approach to printing large die is by using a larger mask. And in conjunction with Bacchus, there was a workshop on large format masks. This is the second time it's been held. It was held last year also in conjunction with Bacchus, and about 70 people attended. This year there were over 150, showing increased interest. I think there was also a fair amount of support for adopting this larger format mask, but it's fair to say the industry has not yet made a commitment. Another topic that got a lot of attention at the conference had to do with masks with curvy features on them. It's been known for a very long time that if you use techniques such as inverse lithography to enhance process windows and pack to higher densities, that the optimum solutions involve features on the masks that are curvy. But we need more infrastructure to support such curvy features. And there were many papers at Bacchus that talked about the development of what we need to fully implement curvy features, and I expect that to be well in place in the not too distant future. One of the key enablers for curvy features are the multi-beam mask writers. There are two suppliers of such tools, and they both gave very nice presentations on their latest multi-beam tools. Users of the multi-beam tools also talked about using it. One of the very interesting applications was an idea where you give much higher doses just along the edges of features, improving edge acuity, and that improves the mask making process. Moreover, there is one technique, pixel level dose correction, that allowed this to be implemented in line with the mask writing, so one did not have to take extra time in the data preparation. All of this is going to be needed because another theme that was talked about by multiple people speaking was the fact that we need to go to very small features. We need these sub-resolution assist features, again, as we implement techniques like inverse lithography. But when you couple that with high NA EUV lithography and it's a very high resolution, it means you have to have very small features on the mask so they don't print. Also, in the mask world, one of the things that people have been working on has to do with what's referred to as the low-end masks. These are the EUV analogs of the attenuated phase shifting mask that we have long used in optical lithography. After many years of development, such masks are now available commercially, and we're starting to see more use of that. An issue that has been a problem that we've dealt with EUV masks for a long time has been defects. One aspect of that is the fact that we haven't had pellicles for EUV lithography, though they've been in development for some time. And again, I think we could see that pellicle use is now starting to expand. A great deal of this has to do with the fact that pellicle technology is maturing, as well as there's just a greater need as we go to smaller features and higher device densities on the mass. And at least one supplier of EUV pellicles announced that they are ramping production, indicating people want these and to use them. On the defect side, again, we need to have good inspection. Deep UV inspection has been extended extraordinarily, but I think it's starting to run out of steam as we make features yet smaller. And so we need to have greater use of actinic pattern mask inspection. That has been adopted somewhat slowly, I think, due to the fact that the tools didn't quite have the desired reliability, but that problem has been addressed and we've seen improvements. And I anticipate greater use of actinic pattern mask defect inspection, again, coming fairly soon. Another area where we have challenges is in the area of resist, particularly related to the issue of stochastics. There, again, good progress is being made. There was an interesting presentation by John Beafor of KLA. They have produced a product that allows prediction of hotspots in layouts that are more susceptible to stochastic defects than might be desired, and therefore one could go in and modify the layouts a bit. But Beafor also made a very interesting observation. He noted that we've tried to understand stochastics by using metrics such as the image log slope or local critical dimension uniformity. And Beafor points out that these really are not the right metrics to be using, as they are metrics for what's happening at the edges of features, while defects are things that occur in the middle. And I think that was a nice observation. We also need to have some better fundamental understanding of what's going on in EUV resists. It's well known that the radiation chemistry of EUV resist does not result directly from the absorption of EUV photons, but rather these EUV photons are absorbed, creating photoelectrons the photoelectrons scatter and creating lower energy secondary electrons. And it's these lower energy electrons that actually directly drive the chemistry. So if we're going to really understand what's going on in resist, we have to have better understanding of the transport of electrons in resist materials. There are multiple laboratories now that are looking at this phenomenon and trying to understand it in more detail. Another interesting type of technology that was presented in the world of resist are those referred to as vertically tailored resists. What these are resists where the molecules basically stand on the substrate vertically. And that allows one to have a large resist molecule, and therefore you could build in all the different functions that are needed, such as high absorptivity to EUV light, good selectivity to etch, and so forth. But the lateral dimensions can be small, allowing for high resolution and, importantly, low line edge roughness. An undercurrent also in several of the talks has to do with sustainability. And in the world of resist, it was good to see that there was one company that was presenting on a PFAS-free electron beam resist that looked like it had some fairly decent performance. So it's good to see that some of the sustainability issues associated with lithography are being addressed. Proceedings, papers, and recordings of many of the presentations will soon be available on SPIE's digital library, making them available for those of us who want to go back and study some of the presentations in more detail. And they're also available for people who are unable to attend the conference. I'm glad I was able to attend the conference in person because it also allowed me to have some nice discussions with colleagues regarding lithographic technologies. So I'm very glad I attended Bacchus this year. And that's my summary of Bacchus 2024. Thank you.